So this first one here should get something that looks like this. How many of you got something that looks like that? Okay, good. That was a little tricky because again, we still got the negatives in there. When you square them, you have to be very careful. If you just punch that in your calculator as one line, you just got to make sure you put the negative in parentheses like this as you enter that. Over here, this one's kind of tricky. You would start like this, and it looks something like that. Now, one thing to note, all of the ones we've graphed so far, I put arrows on both ends. My lines here, and on this parabola for number 3. This one has an arrow on this end, but not here. What does that mean? Well, that means anything smaller than -6 cannot go in there for x. If I put in -7, -7 plus 6 is -1. And if I try to do the square root of -1, my calculator is going to tell me error. It won't let me do that. So I can't have any value less than -1. Or less than -6 for x. Okay, we've got a couple more to try here. I'll give you a couple minutes to try these and see how they turn out for you. Let's look at the first one here at least. You should get something that looks like this. That one's a straight line. The second one, I know many of you probably haven't finished it up yet, but if you enter this in your calculator, this is not 2 times x, it's 2 to the power of x. So you put that in your calculator, it's 2, and hit the caret key or y to the x key, depending on your calculator. Then you do have to put in -2. That should give you 0.25. So at -2.25 is going to be somewhere in there. -1, if you do it, should give you 0.5. 0, anything to the power of 0 is 1. 2 to the power of 1 is 2, and 2 to the power of 2 is 4. You could graph it with those points, or if you wanted more points, you could. You get something that looks like this. Called an exponential curve. That's often used for concentrations of blood. Blood concentrations of IV drug and stuff like that go on an exponential curve. Also, drugs leaving the body go on an inverse curve that would curve the other way. They cut in half they're metabolized to a certain percent every hour or whatever. Okay, these next couple, I'll let you work on number 7 a little bit, but number 8 I'm going to go over with you. I won't make you try that one on your own. Number 8 here, if I put in -8, 8 divided by -8 would be -1. So -8, -1 right there. Put in -4. 8 divided by -4 is -2. So -4, -2. -1, 8 divided by -1 is -8. That's right there. Here's where the funny thing happens. Put in 1. 8 divided by 1 is +8. That's up here. 8 divided by 2 is 4. So 2, 4, that's right there. 8 divided by 8 is 1. Now I could put in some other values if I wanted to and get some other points. Like if x was 4, 8 divided by 4 is 2. Or if x was -2, 8 divided by -2 is -4. I can get those points. But the question is, we can see there, it looks like there's a curve here and a curve here. Oops. The question is, what happens between these 2 points here? And the answer is nothing. Can x be 0? What's 8 divided by 0 on your calculator? Well, 8 divided by 0 is an error. It won't do it. So x cannot be 0. So this line will keep going on and on forever. You get closer and closer to 0, but never equal it. Same here. Closer and closer to the 0, but never equal it. Similar to up here, where this one got closer and closer to 0 going down, but it never quite hit 0. No matter what we put in for x, 2 to the power of x will never be 0. Those are what we call asymptotes. You don't need to know that term, but what it is just a line that it approaches. A lot of behavior in the body is asymptotic, like your blood alcohol levels. Your body metabolizes the blood alcohol, your alcohol in your blood. Technically, the only reason it ever gets down to 0 is because you're limited by the molecular size. Eventually, either the molecule's there or it's not. You can't keep cutting it in half. But that has a very asymptotic behavior. So anyway, number 7, I'm just going to go ahead and we'll do it. Number 7 will look something like this. Like that. I will leave you guys to graph 9 and 10 quick. I'll give you a few minutes. You may not quite have them all done yet, but this one here is going to look something like this. And this one, something like that. So the big point here, obviously, all these graphs look different depending on what their equation is. Some of these you saw I was able to graph rather quickly without really doing much. So you might ask, how do I do that? Is there a shortcut? And many of you know some of the shortcuts already. But when you go to graph equations, the first step in doing it quickly is knowing what shape it's going to be. So one of the first things we need to identify is its shape. And the first shape we're going to look at is a line, graphs that form a straight line. So looking at our graphs here, number 10 formed a straight line. Those two, neither one did. Number 5 made a straight line. Neither one of those two. And then both 1 and 2 made straight lines on the graph. So the question is, as we look through these, and I want you to take a look at the ones circled in blue as I scroll back down, and then the other ones. What is different about these that made lines compared to the ones that didn't? So you can see these two made lines. The two down here did not. 5 made a line, 6 did not. 7 and 8, neither one of those made a line. 10 made a line, but 7, 8, and 9 did not. As we look through those, and more specifically, what do the equations that don't make lines have that the linear ones did not have? That's usually the biggest difference. Well, if we look at them, some of the things that the ones that didn't make lines had, they had powers on the x, on any of the variables actually. X or y would make a difference. Now, like a square root on number 4, a square root is a form of a power. It's an exponent. But I should put in here except for 1. You know, x itself has a power of 1, so we've got to make sure that we allow it to have that. The second thing that they didn't have, like for number 6 there, x is a power, 2 to the power of x. And then I believe it was number 8, where you divide by x. So the list of 3 things I hear are 3 things that linear equations don't have. So if we're going to graph an equation, we can look at it very quickly. If it has any one of these 3 things, we know it will not form a line on our graph. So if I give you the equation y equals 7x plus 52, will that be a line or not? Not. Does it have any of those 3 things? No. So it will be a line on my graph. If I have 3x plus 7y equals 52, will that be a line on the graph? Well, does it have any of those three things? No, it doesn't. So yes, that will also be a line. How about this one? There's powers in it. Is that a problem? Only if the powers are on the variable. Here, that's 3 to the power 2. This is really nothing more than y equals 2x minus 9. So yes, that will also be a straight line. How about this one? That one will not be a straight line because it's x squared. How about this one? Once again, not a straight line because we're dividing by x. We're dividing by 3x, but we're still dividing by x. How about that one? That one is still a line. There's a power, but it's on a number, not on one of the variables. How about this one? No, it's y 7 to the power of x. You cannot have x in the power. Now, I know it's just a few examples. With a little more practice, you could get pretty good at just looking at an equation and telling whether it's going to be a line or not. So now I want to spend some time looking at, if we know it's a line, how can we graph it quickly based on that information? So to do that, I'm going to start out by looking at examples, some of the simplest examples we can of lines. I'm going to start out with the equation y equals x. So if I'm looking at a graph, if I'm graphing y equals x, relatively simple. If x is -5, y is -5. If x is 1, y is 1. If x is 4, y is 4. It gives us a line that goes through the origin, through the center of the graph here, and corner to corner at a 45-degree angle. That is the simplest linear equation we could have. Now, some things I could do to that to make it more complex. I might add to it, like y equals x plus 2. Now, I could do out the data table for this, but we don't have to. Let's just pick some numbers. If x is -5, so -5 here. What is -5 plus 2? It'd be -3, right? So if x is -5, y is -3, something like that. If x is 0, what's 0 plus 2? 2. So if x is 0, y is 2. That would be right there. If x is 3, what's 3 plus 2? 5, right? So 3, 5, right there. What we get is a line that is parallel to the original line, same angle up the graph. What's changed about it? Well, it's just moved up 2 spots. The plus 2 moves it up. Likewise, what do you think would happen with this one then? It moved down 3, and we could do that. If x was 0, 0 minus 3 is -3. If x is 3, 3 minus 3 is 0. That'd be right there. If we plotted more points, we do get that. We get a line that's parallel, just moved down 3 spots. So adding or subtracting to the x moves our equation up or down on the graph from that origin in the center. What if we have this? We multiply the x by something. Well, now if x is 0, 2 times 0 is still 0. We're back to going through the center. But what if x is 1? What's 2 times 1? 2. So 1, 2 right there. If x is 3, what's 2 times 3? 6. So 3, 6. If x is negative 2, what's 2 times negative 2? Negative 4. Good. So negative 2, negative 4. Somewhere in there. Well, we get if I draw my graph straight here, you could line something like that. We notice it's back to going through the center, but now it's steeper. So multiplying makes it steeper. How would we make it shallower, like this? Probably divide, right? In fact, what we're going to do is this. Rather than dividing, we've learned from our fractions that multiplying by the reciprocal is the same thing. So dividing by 3 and multiplying by 1/3 are the same thing. There's a reason why I want it in terms of multiplication. So if that's 1/3, again, if x is 0, 1/3 times 0 is still 0. If x is 3, however, 1/3 times 3 is 1. If x is 6, 1/3 times 6 is 2. We get a line that is shallower, like that. Now, all of our lines so far have gone uphill. How do you think we get a line to go downhill like this? Well, we're changing the steepness. We might do y equals negative 3 times x. That actually would give us a line that looks something like this. So what we have here is there's really only 2 things that can happen to these lines. All lines start out in the center here. And they can move up and down from there, and we can change their angle, their steepness, or what's called the slope. So if I have an equation, y equals 2x minus 3. All graphs start out at the origin, at the center, right there. But the minus 3 here is saying we're going to move down from that 3 spots. In this graph, this line is going to start from down there at negative 3. That quantity is what we call the y-intercept. Intercept, kind of like intersect, means that's where that intersects or crosses the y-axis, is negative 3, or 3 units down from the center. Then the number multiplying the variable, the 2, is called the slope. That tells us how steep this is. Now, right now, all we know is that the 2 means it's a little bit steeper than normal, like that. So let's take some time to talk more about the slope. Slope is a ratio. It is a ratio of rise over run. Rise means up, run means over, like that. So a slope of 2/3 would mean that from one point we go up 1, 2 spots, and then we go over 1, 2, 3 spots. We rise 2 and we run 3. Well, the last graph that we did, it was 2 times x. We said the slope was 2. Well, 2 isn't a fraction. So where's the rise and the run there? Well, it really is a fraction. It can be turned into a fraction by doing what? 2 over 1. So what that's saying is from a starting point, we would go up 1, 2. We'd rise 2, and we'd run 1. That starting point on our graph is that y-intercept, that number that's added or subtracted. So I could graph very quickly y equals 3/4 x plus 2. I would start out at positive 2 right here. That's my starting point. 2 up from the center. And then 3/4 means I rise how much? 3. And I run 4. 1, 2, 3, 4. There's my second point right there. So my line goes through those 2 points. There's my line. Y equals 2x minus 5. Where's that one going to start? negative 5 right here. So we're going to go down 5 from the center. Right there's where it starts. Now it has a slope of 2, so I make that 2 over 1. So from this point I rise 2 and I run 1 right there. Y equals a negative 2/3 x plus 1. Where's this one going to start? Positive 1 right there. And now we have a negative 2/3. When we're dealing with slope, the negative usually is put with the rise. We're always, for our purposes, we're always going to put the negative with the rise. So a negative 2/3 means from this point, we don't rise, we don't go up 2, we go down 1, 2. And then we're going to run 3. So 1, 2, 3. So there's our negative 2/3 slope. Or we could have y equals negative 3x minus 1. Where's that one going to start? Negative 1. And from there, negative 3 over 1 means we go down 1, 2, 3, and over 1. Like that. How about this one? Y equals 5 minus 1/2 x. Where's that one going to start? Starting at the 5. 1, 2, 3, 4, 5. We're used to that number being at the end. All of these, it was at the end, but here it doesn't matter. It's the number that's added or subtracted. It's a positive 5. So we start at positive 5. Then x is multiplied by a negative 2. So we go down 1, run 2. There we go. Pretend that line's straight. Now, not all of our equations are that neatly laid out for us. We might have an equation that looks like this. Now, for that equation, what's different here? Well, all of the equations we've looked at so far have been of the form y equals something. Y equals negative 3x minus 1. Y equals negative 2/3 x plus 1. This is y plus 2 equals. We have to have it in that form, y equals. So we have to get rid of the plus 2 by subtracting 2. So we subtract 2 and it is gone. Now when we add or subtract from one side of the equation, we must do the same to the other side, obviously. But when we add or subtract, we only have to do it to one piece on each side of the equation. We were able to subtract 2 from that. We didn't have to subtract 2 from the y. We just had to subtract it from the 2. So on the other side over here, I only have to subtract 2 from one piece. Well, I can't take it from 3x, so I'm going to have to subtract 2 from the negative 1. So this is 3x. Negative 1 minus 2 is negative 3. So now I'm going to graph that starting at negative 3. And this is a 3 over 1, so that's going to go up 3 over 1. There's my graph. Now, similar to that, I can have an equation like this. What's different here is y has been multiplied by 3. So in order to do anything with that, I have to get rid of the 3. It's multiplying y, so I need to divide by 3. So that'd take that away, leaving me with y. But when I multiply or divide an equation, I have to multiply or divide every piece on each side. So over here, I have to divide this whole thing by 3. Each piece gets divided by 3. 2/3 divided by 3 looks like it's going to be ugly, but we don't want it as a decimal. We want it left as a fraction or a ratio. So 2x divided by 3 is just 2 divided by 3, or 2/3, times x. 6 divided by 3 is a positive 2. So here we start out at positive 2. Bless you. Then 2/3 means we rise 2 and run 3. That. Bless you again. Allergic to math? So here's our equal sign. Y is, or that should be a y, not an x there. Sorry about that. 2y minus 3. We have to get y by itself again. It has to be y equals. Well, here y has been multiplied by 2 and 3 has been subtracted from it. So to solve, we've got to add 3, leaving us with 2y. Now again, when we add or subtract, we only have to do it to one piece on each side. So over here, all I have to do is add 3 to the negative 5. This is 5x minus 2. And then we need to divide by 2. Makes that go away. When we multiply or divide, we have to do it to every piece on each side. 5x divided by 2 is just 5 over 2x. Negative 2 divided by 2 is a negative 1. So we start graphing this at negative 1 right here. Then 5 over 2x, we rise 1, 2, 3, 4, 5. We run 2. There's our line. Something like this is a little bit more complicated yet. X and Y are both on the left side of the graph. We want Y to be by itself. We want one on each side. So I'm going to have to move X over to the other side of my graph. To do that, I'm just going to subtract 5x. It's gone over here. On the other side, I have to subtract 5x as well. So I have negative 3y left here. On the other side, 9 minus 5x is just 9 minus 5x. And then I have to divide by the negative 3, leaving me with y. Again, I have to divide every piece on the other side by negative 3. 9 divided by negative 3 is negative 3. Negative 5x divided by negative 3. Well, that's just going to be negative 5 over negative 3 is a positive 5 over 3x. So we're going to start out at negative 3. And from there we're going to rise 1, 2, 3, 4, 5 and run 3. There's my graph. So I want to have you guys try a couple of these in your notes quick before we run out of time. So I want you to graph y equals negative 2x plus 3. I also want you to graph (3y plus 1) equals 2x. 2x minus 5. And I want you to graph 2x plus 5y equals 10. So let's try those. We'll discuss those in a couple minutes. So the first one up here, we're just going to start at positive 3. And then, of course, it's negative 2, so it's negative 2 over 1. So we're going to go down 2 over 1. Down 2 over 1, like that. The second one, we have to get y by itself. So we have to subtract 1. So we've got 3y equals 2x minus 6. And then divide by 3. So we got y equals 2/3 x minus 2. So we start at negative 2. And that's up 2 over 3. Like that. And then finally, this one we have to subtract 2x, get 5y equals 10 minus 2x. and then divide by 5. So y equals 10 divided by 5 is 2. Negative 2 divided by negative 2x divided by 5 is negative 2/5 x. So we start out at positive 2. Then negative 2/5 means we go down 2 over 1, 2, 3, 4, 5. Hopefully you got all three of those to turn out somewhat close to that. In your book, some pages that relate to this stuff. Y equals page 205. There's just problems 1 through 3 looking at graphs. Page 213. It's actually 213 through 217. 1 through 15 if you just want to do the odds. Page 221 through 222. 1 through 15, again, if you just look at the odds. And then I don't believe we got to page 226. So that's what we'll start out next time, is the stuff on page 226. So with that, you guys have a great weekend. We'll see you next week. Remember, Unit 4 test is 2 weeks from today.